Hi, I'm Quantic, and today I'm going to answer a question that many developers have in mind. What is serverless, also known as function as a service, and is it worth it? First off, what is serverless? Serverless, or function as a service, means you write and deploy individual functions rather than entire apps. Each function handles a distinct need and handles a distinct event, like a web request. This is the reason as to why serverless is also called function as a service. The functions you write are only loaded to the memory when there's a request or an event for them to handle, and they are unloaded from the memory after they are done. They also share the same hardware, even possibly the same runtime with everybody else's functions. As a result, you only pay for the CPU and other resources consumed by your functions and not the entire server or the VM. Let's see an example of how serverless works in a simplified diagram. Check this out. The diagram starts with the client on top. The client could be a browser, could be a mobile app, could be another internal service. The client sends a request to, say, Firebase Functions, which hosts the target domain and the API endpoints at mysite.com. Internally, the request is handled by a load balancer. Load balancer chooses a server with low utilization, and that server loads the code and dependencies for your functions and executes it. The server can be handling many functions at the same time for many unrelated domains. Each request to your functions can be executed by different servers. This is at the load balancer's discretion. Now I'm going to give you a quick example of how serverless works. I'm going to implement a simple getDate function using Firebase Functions. Check this out. I'm going to implement a getDate function using Firebase Functions. Remember, Firebase has a generous free quota, so you will not have to pay anything for the sample project. I'm going to start by installing Firebase tools using npm install g, so it will become a globally accessible command line tool. After the installation is done, I'm going to log in to Firebase using Firebase login. If you don't have an account, you can create it that step. And I will continue by typing Firebase init functions. So it's going to create a template for our new function. You can exist in project or create a brand new one. As long as you give it a unique ID and any name, you should be fine. Wait for your project to be created, and we will be ready to go ahead and edit it. Depending on the Firebase CLI tool you used, you will be asked several questions about the styling, about linting, etc. You can choose as you wish. After our template is ready, I'm going to pop open my code editor and go into index.js and uncomment the commented template block, which is a simple hello world function which is all ready to be deployed. So after saving the file, I'm going to go ahead and type Firebase deploy, which will deploy our first function to our newly created project. After the deployment is done, we will get the publicly accessible URL for that function so we can test it. I'm going to copy it, I'm going to paste it in a new window, and I'm going to curl to it, and there it is. Hello from Firebase. That's the return value that we were expecting. Now go ahead and create our getDate function. I'm going to copy paste the exact same code block, and I'm just going to change the return type to a new date, which will print the current server date. And I'm going to do a Firebase deploy again, and after the deployment is successful again, we're going to get the publicly accessible URL. Let's go ahead and copy that URL so we can curl to it, and there we go. Our getDate function currently perfectly functional, and that's it. If you want, you can add authentication to it, or you can attach more Firebase services to it. Once you access your functions, you can access your logs or the errors that happen during that access. Let's go ahead and check out our logs. I'm going to blur out some sections to hide some sensitive information. Sorry for that. And there it is. Our access logs for our functions, very detailed. And you can go ahead and check out the usage to inspect access counts. If you want to see the logs just for a specific function itself, you can do so from the menu item. And once you are done with your project, you can go ahead and delete it from the project settings page. And that's it. Simple as that. In just a couple of minutes, you have your first functions up and running. Now let's start with the benefits of serverless. Low cost development. Very little to learn or care about. Most of the chores are already handled for you. The SDKs and documentations are very clear and concise. You are only built for function executions based on the time and other resources consumed. You only pay for processing power, memory, bandwidth, and other resources. If your functions are sleeping, you pay nothing. There are no ongoing costs, unlike a real server. Little to no DevOps. No server maintenance. No security patches or OS installations to handle. No network maintenance. Disaster recovery is automatic. Logging and auditing are built in. Deployment, versioning, and reverting is easy. And SSL certificates are automatically handled for you. Automatic scaling. Serverless functions can be scaled pretty easily. Since functions are stateless, you are forced to use scalable solutions right from the start. Functions do not need to be public. They can be private functions handling only internal events. For instance, you can create a function to handle only AWS file uploaded events. And using that function, you can apply post-processing to images uploaded by your users. Providers also allow timed functions, which run at predetermined intervals. You can use them as cron jobs to perform routine tasks. I'm sure you can come up with many innovative ways to use functions in your backend. You can handle pretty much all your backend workload in an event-driven fashion with minimal costs. Do not forget, the cost of labor is much higher than the cost of serverless. If you decide to go with AWS EC2 servers, you still have to learn AWS, which is a titanic task in itself. Somewhat. Now let's talk about the drawbacks. First is the vendor lock-in. You will have to use the vendor's SDK and have to write vendor-specific code, unfortunately. Your API design will be based on the toolset supported by your provider, rather than the optimum tools available. You are bound to couple your functions with vendor-specified tools to process state, to handle file uploads, to create WebSockets, etc. On the other hand, you are almost always vendor locked in. Changing your vendor is a major investment, and it's almost never easy, no matter what technology you use. No persistent connections, as functions are only allowed to run for a certain amount of time. On the bright side, some of the vendors give you the option to use WebSockets through other means. For instance, you can access WebSocket API through Amazon API Gateway from inside your Amazon Lambda functions. However, this adds complexity. Serverless is an order of magnitude more expensive than AWS EC2 servers, which in return is an order of magnitude more expensive than bare metal servers. If you are cost sensitive, using a bare metal server in your home network or just attaching a Raspberry Pi could be a cost-effective option. Do not forget, the DevOps will eventually cost you more. You need to utilize other services like Firebase authentication whenever possible. This will delegate some of the work from your functions to other web services, which will decrease your costs. Limited programming language availability. Not all providers support all the programming languages and runtimes, and due to this, you will be restricted by your library choices. And not every library might work 100%. For instance, you might not be able to use gRPC out of the box. No local state. Once your function execution is complete, all the memory held by your functions is released. Anything you store in the memory will be lost. Best is to store your temporary state in Redis or Memcached or other tools provided by your vendor. On the bright side, this forces you to create stateless functions which are easily scalable, so scaling in the future won't be such a headache. As always, you will have to store long-term state in a database. Your functions share the same server or even the same runtime with other people's functions. Obviously, this is always a security concern in case the sandboxing is breached or is buggy. Lately, there have been quite innovative attacks on sandboxing using side channels. I won't go into detail as it is a complex subject, but you can Google for more information. Local development, debugging, and testing will require specialized tooling from the vendor. On the bright side, most serverless providers have local emulators and mock libraries to help you with that. Cold starts. Cold starts of your functions will be costly. For instance, if you are using JavaScript, all the libraries will be loaded and interpreted again every time a function is loaded into the memory. On the other hand, vendors are coming with ingenious ways to solve this problem. While choosing a vendor, consider cold startup performance of their functions. Cache whatever you can to reduce the impact of cold startups. Different vendors offer different tooling for caching. Utilize them. 5 years ago, we were discussing if AWS EC2 servers were viable alternatives to bare metal servers. And today, we are discussing if serverless is a viable alternative to AWS EC2 servers. Just as we gain confidence in AWS, I'm pretty sure serverless will gain traction in the future. Now let's talk about the alternatives. First, Heroku. Heroku, it is my personal favorite. You still write old school traditional server apps, but scaling, DevOps, and deployment is automatically handled for you. It is great and easy to use tooling. Also, you can deploy projects with a single button click. Check out the video description below. I have a great example of one-click deployment to Heroku. 2. Google App Engine. It is just like Heroku, a great midway between serverless and VMs. As an example, Snapchat's fast development and its success is attributed to Google App Engine and its ease of use. 3. Serverless.com. It is an open source serverless app framework. It abstracts away all the serverless providers, giving you a unified interface. The downside is it adds complexity. 4. Containers using Docker and Kubernetes. Containers abstract away all hosting providers. They can run on the cloud, on bare metal, or even Raspberry Pi. On the other hand, they require more maintenance and have a much steeper learning curve, not to mention the fact that more abstraction means more obscure errors. Some of the serverless providers are starting to offer stateless containers as an alternative. I must say, I don't have any experience with those, so use at your own risk. If you like this type of tech analysis videos, subscribe to the channel now. If you have something to add on the subject, or have a question, or if you disagree on a point, let me know in the comments section down below. Now let me answer the question, who uses serverless? Many big corps use serverless today, and many others will join the ranks in the coming years. Since they are so versatile, they can be used in handling many internal tasks. However, notable examples that use function as a server providers as the backbone of their businesses are as following. As I mentioned, Snapchat is built on Google App Engine. They signed a $2 billion 5-year contract with Google Cloud Services in 2017. That probably made them the largest serverless deployment on earth at the time. So if you are experienced with serverless and want to work for Snapchat, knock on their door. Netflix. Netflix is slowly switching to serverless. As they put it, they are creating a rule-based, self-managing infrastructure using AWS Lambda. They are using event-based triggers to automate the encoding of media files, validation of backup completions, and deployment at scale. iRobot, the creator of Roomba robotic vacuum cleaner. iRobot is creating their IoT platform using AWS Lambda, and as they say, it is only managed by 10 people. Reddit. Reddit's video hosting service is built and maintained by a single engineer on serverless stack. If you are looking to convince your managers to invest in serverless stacks, go ahead and Google for more case studies. There are a great many of them which can inspire your colleagues and your managers to give serverless a try. Serverless is all about bringing your project to the market as fast as possible with as little mistake as possible. The companies that I just mentioned executed that perfectly and became successful. Let's get to my personal experience. My personal experience with serverless is a mixed bag. Last year, I tried using it for the server side of one of my open source projects. However, I could not do that, since none of the serverless providers supported the latest version of Node.js, which I needed for the async await support. I recently checked it again, and Firebase Functions support the latest LTS version of Node.js now. I also tried using serverless for one of my games. That also failed, since I needed persistent connections during the gameplay. No serverless providers provided a way of using WebSockets in a sensible manner at the time. This has also changed. Amazon now supports creating WebSocket connections through their API gateway, which is accessible through AWS Lambda functions. On the positive side, I've successfully managed to use Firebase Functions to handle Firebase authentication events in one of my open source projects. When one of the users log in, Firebase authentication triggers my authentication handler function. That function checks if the user is logging in for the first time, so I can create relevant database tables for that user. I still use it today, and it is working great. If you want to experiment with serverless, I recommend going with Firebase Functions. It is the easiest of the bunch, and they have a great free tier. Now my recommendations on serverless. I recommend giving serverless a go for your next project. You can quickly come up with a proof of concept version of your project and demonstrate it to the stakeholders. After you hold discussions around this proof of concept and iterate over your design, you can then decide if you want to go ahead with serverless or switch back to regular VM servers. Don't forget, you still need to factor in all the pluses and minuses that I mentioned in this video while making a decision. On the other hand, I do not recommend converting an existing project to serverless. The caveats are too much to handle for an existing project with pre-existing limitations. If you like this type of tech analysis, give the video a thumbs up. Based on your feedback, I'll create more of these in the future. Conclusion. Currently, serverless is in usable state if you can live with its limitations. On the other hand, it is fast improving. Will it outpace other technologies like containers? We'll see about that. As I said, my personal favorite is still Heroku. It is a nice compromise between serverless and cloud servers. However, I still recommend giving serverless a try, even if it is just for the education. I also highly recommend Docker and Kubernetes if they fit your project, but don't forget, they have a much steeper learning curve. That is it for this video. Good luck on your serverless journey. See you next time.